Hello, in this video we are going to look at Pythagoras' theorem. I'm going to focus on the basics of Pythagoras' theorem. There are some harder questions other than what is featured in this video. However, for the purpose of learning and knowing how to use Pythagoras' theorem, this video I hope will be useful to you. So, Pythagoras' theorem is given by a squared plus b squared is equal to c squared. It can only be used in right-angled triangles, and it is really important that we know where to label each of these sides before we start calculating the length of a missing side. So, A and B, it doesn't massively matter where they are. However, C is our most important one that we need to put onto our diagram first of all. C is always labelled as the hypotenuse, and the hypotenuse is always the side that is opposite the right angle. So once you've identified where your right angle is, look opposite, and the side opposite that right angle is the hypotenuse. So I can label that C. As I said just a minute ago, it doesn't matter which sides are labelled A and B. Here's my right angle. Therefore that's my side opposite the right angle, the hypotenuse. So I'm going to label that one C, and then I shall label the other two A and B. In this one, here's my right angle, therefore this must be my hypotenuse. So I'll label that one C, and then A and B. It doesn't actually matter which way round the A and the B go, as long as that C is labelled as the hypotenuse. So our first example is, if I can calculate the value of x. So here's my right angled triangle. I'm going to need to label my sides. So let's label C first of all. There's the right angle, that must be my hypotenuse, and therefore this must be C. The other two, it doesn't matter which one is A and which one is B. The first thing I'm going to do is to write out my formula. So A squared plus B squared is equal to C squared. Now I've got that set up, I'm just going to put in my value for A into the formula, my B, and also my C. So A is 9.4, so 9.4 squared, plus B, which is 15, so that's going to be 15 squared, and that is equal to x squared, because that's what C is. Now I've got this set up, I can type this into my calculator. So I'm going to put 9.4 into brackets, 9.4 squared plus 15 squared, and I get this value here, 7,834 over 25. I can convert that to a decimal if I want to. So I'm going to write here, this part here is equal to 313.36, and I know that is equal to x squared. The question asks us for x, not x squared, so I'm going to need to get rid of this squared, and I'm going to need to square root both sides. So I'm going to want the square root of 313.36, and I know that must be equal to x, because I've got rid of that x squared by square rooting, so I'm just left with the x now. I then clear off my calculator, press the square root button, so square root, and then I can use the answer button, A and S, that uses the previous answer that was on the calculator before I cleared it off. So you can see here I've got A and S in there. Press equals, and I get my value. So I have got x is equal to 17.70197729. I'm going to round that to three significant figures, to 17.7, and my units are centimetres. That is our first example. My second example is slightly different. Now this is different because if I have a look and I start labelling my triangle, here's my right angle, therefore this must be my hypotenuse. This time I have got a value for C and I'm going to have to work out either A or B. It doesn't matter which way you label them. I'm going to label that one A and that one B. I'm going to start by writing out my formula so I know how it all fits together. A squared plus B squared is equal to C squared. And then I can start substituting in my values. M is what I'm looking for, calculate the value of M. M is the value of A this time, so M squared plus B is 31, so 31 squared, and that must be equal to C squared, so 53 squared. Now this is an equation. I don't have the M squared on my own, so I cannot just square root straight away. What I'm going to need to do is I'm going to need to subtract this 31 squared from both sides. So that leaves me here with M squared is equal to, that 53 squared is still there, so 53 squared, and then I want to take away the 31 squared. So I've taken away the 31 squared from both sides, as you can see here, and then I can type this into my calculator. Please watch out, you do not want to do 53 take away 31 and then square the answer. You need to do 53 squared take away the 31 squared. So I type that into my calculator. 53 squared minus the 31 squared is equal to 1848. So M squared is equal to 1848. I need to get rid of the square, so I square root both sides. M is equal to the square root of 1848. I do need to make sure I'm showing the workings, so whoever is marking the work knows the method and the process that I'm doing. Clear it off, press your square root button and the answer button that's next to the equals. You will see that A and S up there in your square root. Press equals and you get this answer, 2 root 462. That is a perfectly acceptable answer. However, if it asks us to round it to a number of significant figures, we have got 42.98837, so we could say that that's 43 meters. Okay, our third example is PQR is a right angled triangle. PQ is 24 centimeters, QR is 18 centimeters, and the angle PQR, this sign means the angle PQR is 90 degrees. Calculate the length of PR. Before you do this question, I would strongly recommend that you draw a diagram so that you can visualize what's actually going on in the question. So I'm going to draw my right angled triangle. I'm told it's got a right angle and I'm told where that right angle is. So I'm going to label the points, the corners of, or the angles outside of the triangle. I'm going to label that one P, that one Q, and that one R. So P, Q, R, I'm told that the angle at Q, which is why I knew Q had to be at this point here where the right angle is, because that's where it says in the question the angle at Q, P, Q, R, P to Q to R is 90 degrees. So I had to draw it this way round. I can now label on. PQ is 24. So PQ must be this length. So this is 24 centimeters. And QR, I'm told this length here, QR is 18 centimeters. Calculate the length of PR. That must be that length there. So I suppose we can say we know that that's going to be C because it's opposite the right angle. I can just label it C. I know that's what it's going to be. And then I can label A and B for my other two sides. First thing I'm going to do, write out the formula. A squared plus B squared equals C squared. And the next thing, substitute the values in. 24 squared plus 18 squared, and that is equal to C squared. Type it in. 24 squared plus 18 squared, I get 900. So 900 is equal to C squared. Square root both sides. Square root of 900 is my value for C. Square root A and S button. So square root that previous answer, square root of 900 is 30. 30 is my value for C. And don't forget to just finish it off with those units as well. Centimetres, centimetres. Okay, one last example. A line joins the coordinates 5, 11 and minus 3, 20. Calculate the length of the line that joins these two coordinates. Again, I've got no triangle and it's not clear to see what this actually looks like. So I'm just going to draw a very rough sketch as to what this may look like. That's a pencil, sorry. So, very small sketch here. So I have got 5, 11, doesn't have to be to scale, just to give us an idea. That's going to be that coordinate. 5 to the right and 11 up, definitely not to scale, but it doesn't matter really. And then the next coordinate, minus 3, 20, is going to be minus 3 and then 20. So that's just a visual as to what this is going to look like, and that is the line that joins them. What I'm going to do now is actually draw this so it looks a bit more like a triangle. I can see here I've got 2 points and the line that joins them. So I hope that you're happy that I can draw a diagonal line like that and say that is the point minus 3, 20, and that is the point 5, 11 from what we just looked at above here. I can now make this into a right angled triangle, because eventually if I was to draw a line going down here and then a line going across here, they are going to meet at 90 degrees, and I hope that that makes sense and you can see that. Now, how do I know what the lengths are? Because I've got coordinates, but I don't know what the distance is. Let's label the sides first of all. So, right angle, that must be C. Doesn't matter which one's A and B, I'm going to go that one's A and that one's B. Now, how do we work out the values? We know that C is the one that we're going to have to find, because the question asked us to find the length of the line that joins these 2 points. I now need to know how big this distance is. Well, if I look at this value here and this value here, I know that the distance between 11 and 20 to go up, to get up all the way to 20, that would be 9. Likewise, with minus 3, to count up to get to 5, I'd have to count up 3 to get to 0, and then up a further 5 to get up to 5. So in total, that is going to be 8. The distance between minus 3 and 5 is 8. You can draw yourself a number line if you're not 100% sure. Minus 3 up to 5. I've added 3 to get to 0, and then I've added 5 to get up to 5. So in total, I have added 8 You could do the same for the 20 and the 11. You can see, right, I started at 11, I need to get up to 20. I can see that I've added 9 to get there. Now I have got my numbers that I want to work with, I can now work out what c is. So a squared plus b squared, this is the bit that takes me a long time, sorry, plus b squared is equal to c squared. Substituting, so 9 squared plus 8 squared is equal to c squared. Type into my calculator, 9 squared plus 8 squared gets me a value of 145. So 145 is equal to c squared. Square root both sides. Square root my answer. And I get let's go, c equals 12.04159458. So the length of that line is 12 units. I hope that has helped, and good luck with your Pythagoras theorem questions going forward.